In exercise 803, we're going to look at the sine rule, not to be confused with the sine ratio. It's the sine rule. The biggest difference between this exercise and the previous exercises also is that we're moving away from right angle triangles. The triangles now will be non-right angle, and you can see that here. And just before we move to looking at the actual sine rule, you have to understand the lettering in the rule, and to do that you need to be aware that when we've got a triangle, all angles are labelled with capital letters. So let's just go A, B, C, using a capital letter. Anytime now you see a capital letter, it's referring to an angle. And you must also understand that the sides are named with lowercase letters. So there's a real difference now between a capital A and a lowercase a, and we really have to be tuned into that. We name the side according to the angle that it's opposite. So for this side here, between A and B, rather than having to decide is it a lower A or is it a lower B, it's neither, because it's named according to the angle that it's opposite. So it's opposite angle C, and it's a lowercase c. The side down here is between angles C and B, but that's not how it's named. It is named with the lowercase letter of the angle that it is opposite. So you can all see it's an A. And this side over here would be a lowercase b. Really important that you're tuned into the difference between capital letters and lowercase letters, because they're referring to two very different things. So let's move on to the rule. The sine rule is rather unusual because it's got two equal signs. But to be honest, we do this. We go back to our maths, which only has one equal sign in it, to establish an equation. So some of this rule we're going to ignore. Let's get a bit of an understanding about what the rule actually says. It says, if you take this lowercase a, now what's our understanding of a? Anything lowercase is a side. So this is referring to a side. What particular side? It's the side opposite angle A. Now, it's no coincidence, and in fact it must always be the case that what's in the bottom of this fraction is the sine of the angle A. So these two really closely linked, angle A and side A. And in fact, you can put the length of a side over the sine of the angle that it is opposite, and you can make a fraction. And that's what you'll see us do in these examples. And what do we know it's equal to? Well, it's now equal to whatever the length of side B is over the sine of the angle B. So it's really important to know that these two fractions are equal to one another. And I'm sure you can see that what that allows us to do is to write an equation. What do we do once we've got an equation? One part of it's going to be unknown, and we're going to solve for that unknown part. So once we've got the equation, we solve the equation. To get the equation, we're going to use the sine rule. And of course then this third side over the sine of the angle it's opposite would be equal to these as well. But like I said, we will only ever be using two of these. It doesn't matter which two you use. You could choose that one and that one. It really doesn't matter. Okay, let's have a look. It says, and just before we do, you can see that if I write the rule A on sine A, if I just use the first two, sine B, there are 1, 2, 3, 4 components to that equation, 4 things. Now what do we know for it to be an equation we can solve? We have to have the numbers for 3 of those. There can only be one unknown. So let's say A is the unknown. This is the only one we don't know. That means we have to know a number for there, a number for there, and a number for there. If that should be the case, then we would be finding A. What do we know A is? We'd be finding a side. Great. We can use the sine rule to find a side. Or, if on the other hand, we knew A, we knew the angle A, we knew B, but we didn't know this angle, this was the unknown, then again, we could use that rule to find that angle. So we can use this rule to find either a side or an angle. So just be aware of that, side or angle. That's a really useful rule. So in this triangle, what do you recognise? Do you recognise that this is the unknown? It is a lowercase y. It's a lowercase y. It's a side. Clearly it's a side. Here we've got the angle that it is opposite. Here we've got another angle, and we've got the side opposite that one. That's really nice and convenient, and it's the way it has to be. Side, angle opposite that side. Next side, got to know the angle opposite it. So, a little 4-step, again, method for you to follow in order to be able to find this side. And note this triangle is not right angled. It's not right angled. We're not using the sine ratio, we're using the sine rule. It says label the given angles A and B. Okay, let's say I call this one angle A and this angle, angle B. Now, using our labeling method, we have no choice but to call the side opposite A, we're going to call this lowercase a. The side opposite B, angle B, has to be called lowercase b. So we've labelled the angles, we've labelled the sides. We're going to use the sine rule. So let's set up the sine rule. The sine rule is A on sine A equals B on sine B. We need to substitute into that. We've got 4 unknowns at the moment. So let's substitute what information we've got in our diagram. A is actually called Y. Great, that's going to be the thing we find. And then we've got sine of A is sine of 51. What do we know about that? We know that that is a number stored in the calculator. Great, we've got a number that could go in that spot. I'm probably not going to write it because it's probably a number with 7 decimal places. I don't want to get them wrong, so I'm just going to call it sine 51, knowing it's a number. Let's move on. Got our equal sign, our B. B is 3.6 over sine, and again, where's angle B? It's this 22. And what do we know about that? It's a number stored in the calculator, and I'm probably not going to put the value in there because I might get some of the digits wrong. What have I created? I've created an equation. What can I do to that equation? I can solve it. How do I solve it? Means I want to get that y by itself. Well, to get that y by itself, if I simply multiply this side by sine 51, then I'll have to multiply this side by sine 51. That would be great. That cancels them out. That's why I did it. And I've got y is equal to this calculation, 3.6 on the sine of 22 times the sine of 51. Now you can see that I've done that, done that there. Just be careful, you must close your bracket. you must make sure you've got the D in degrees on your calculator. They're some of the reasons that you won't get the correct answer, because you don't close the bracket here or your calculator's not in degrees. So we'll calculate that, and we're getting 7.468 and rounded to 2 decimal places. Cutting off here, the 8 rounds the 6 up to a 7. 7.47, what would the appropriate unit be? We were finding a side, so it's a measurement, and the units that's been established from the information given in the question are centimetres. In this next example, there's a little bit of a complication. Now it says angle RST, angle R is 35, yep, we can see that. Angle S is 67. T, lowercase t, so that's a side. T, yes, that would be T, is 70. And find R. R is down here. Now, R and R nicely go together. R and R. We've got a side opposite an angle. Do you note that we don't know anything about side S? We've got side T, but we don't know anything about angle T. There is no reason why the sine rule couldn't be written in terms of R and S and T. So you can see that I've written that there. Let's have a look. R, no, we don't know R. Sine of R, yes, sine would be sine 35. That's a number. Let me just highlight that because that's a number. That's all good. Side S, we know nothing about side S. We know angle S is 67. That's a number. Do we know T? T is 70. Do we know the sine of T? No. We've only got 2 pieces of information. We know that that's not going to work. It is definitely not going to work. Now, what we know that we have to have 3 pieces of information, 3 out of the 4. So we've got some work. Like I said, this is complicated. I do have that as a whoops, I want to highlight that, I know. Is there any way that we could get this one? Because if I knew this, I could pair up the R and the T. I could pair up these two, and I would, if I knew the size of the angle T. Well, actually, yes, that's not a difficult question to get the angle for T. What do we know about the 3 angles of a triangle? I think some of you indicated to me back in last term that you weren't sure about this, but there is a rule that says the 3 angles of a triangle will always add to give 180 degrees. We've got 2 of them. The third angle, in this case, is called T, which, keep in mind, that's actually what we want to complete our 3 out of 4. And that must always equal 180. So that allows me to create an equation that the 3 angles add up to give 180. So if we complete that solving for T, getting T by itself, subtract 35, subtract 67, we get that angle T is 78. And that's great. That enables me then to write R as my unknown, sine 35 is a number, side T is 70 on sine 78, which is a number. Now I've got 3 out of the 4 as numbers, and I can solve that. And when you do that calculation, you'll get 41.047. It asks for 1 decimal place, and it's 41.0.